that still needs conditioning. The visible movement may take less than a minute, but it carries the work of planners, engineers, technicians, meteorologists, grid operators, environmental reviewers, and local crews. They ask how the wind behaves, how the machine should respond, how power will leave the site, what parts will wear first, and what happens when the weather changes fast. The risk is that electricity must be controlled before it can safely join the wider grid. That risk does not make wind power reckless. It makes it disciplined. Good wind engineering turns uncertainty into procedure, measured air, controlled blades, protected equipment, monitored vibration, planned maintenance, and electrical systems that know how to disconnect when they must. In the end, the quiet spin becomes useful only after it is translated. That is why the chapter on generators matters to the whole story. Yaw control. A turbine has to face the wind without chasing every twitch of it. Yaw control begins with turning the whole nacelle toward useful flow. A wind turbine can look simple from far away. 3 blades, a tall tower, and a slow-turning shape against the sky. Up close, it is a negotiation among weather, structure, software, electricity, maintenance, and the grid. The machine does not command the wind. It accepts the useful part of it and survives the rest. The engineering is made from wind vanes, anemometers, yaw motors, yaw bearings, cable twist, deadbands, directional averaging, and braking. Each piece has to match the others. A wide rotor needs the right tower. A wide rotor needs a tower that can take bending. A generator needs electronics that can shape its output. A control system needs sensors that tell the truth quickly. When the system works, the blades seem calm, but that calm comes from many limits being respected at once. You can see the idea in a nacelle slowly rotating after the wind direction changes across a ridge. The visible movement may take less than a minute, but it carries the work of planners, engineers, technicians, meteorologists, grid operators, environmental reviewers, and local crews. They ask how the wind behaves, how the machine should respond, how power will leave the site, what parts will wear first, and what happens when